So this video is all about proving a certain type of limit. So here we go. We want to prove that the limit as x approaches 3 of 5x plus 2 equals 17. I'm telling you the limit is 17. I'm going to prove it. So the first thing we need to do is to recall what it means to prove a limit. And that is, so we got for all epsilon greater than 0, so this is for all epsilon greater than 0, there exists a delta greater than 0, such that when the absolute value of x minus 3 is between 0 and delta, that implies or will guarantee that the absolute value of 5x plus 2 minus 17 is less than epsilon. This is the x minus a over here, and this is the f of x minus L over there. So we're just going to use that proof. Okay, so we're going to let delta equal epsilon over 5. Now, don't worry about where that came from. I just made it up. Then, if the absolute value of x minus 3 is between 0 and delta, we know that the absolute value of x minus 3 is less than epsilon over 5. Now, why is that? So think about that for a second, then I'm going to tell you, okay, the reason is because delta and epsilon over 5 are the same thing. Therefore, I can replace delta with epsilon over 5. So we know that the absolute value of x minus 3 is less than epsilon over 5, so we're going to multiply both sides by 5, and then we're going to distribute the 5 through, and so I end up with the absolute value of 5x minus 15 is less than epsilon, and then I'm going to cleverly rewrite that like this. The absolute value of 5x plus 2 minus 17 is less than epsilon. But wait a minute, isn't that what I wanted? But wait a minute, isn't that what I wanted? Little happy face. So QED, which means it's Latin for which is what was to be shown. Quid estratum demonstratum, or something like that. A math little joke is quite easily done, but that's another story. Okay, prove that the limit as x approaches negative 4 of negative 3 halves x minus 12 is equal to negative 6. Well, let's see how that one goes. I'll give you a chance. See if you want to guess what delta is going to be. Did it times up? Yes, let delta equal to 2/3 epsilon. And again, don't worry about where that comes from. So, well, if 0 is less than the absolute value of x minus a negative 4 is less than delta, we know that the absolute value of x plus 4 is less than 2/3 epsilon. Again, for the same reason it was before, because epsilon and delta and 2/3 epsilon are the same thing, so I can replace delta with 2/3 epsilon. So, we're going to multiply both sides by 3 halves, distribute the 3 halves, multiply both the inside by negative 1. This is the part you got to be a little bit careful of. Remember, if I take the inside, which is 3 halves x plus 6, I can multiply it all by negative 1, and it's still the same thing because it's absolute value. And then I cleverly rewrite that like that. But wait a minute, isn't that f of x minus L? And if you said yes, then of course you're right, and we're done. So we started with what we needed, and we guaranteed, we started with if this condition holds, then we show that that condition holds. Okay, are you impressed? Don't be. Actually, I cheated. So here's how the process really works. Let's work on finding and improving the limit as x approaches 2 of 5 halves x plus 3. Well, the limit looks to be 8. So here's what I really did. Well, really not, because I knew what I was doing, but this is how the process looks to a beginner. I ultimately need the absolute value of f of x minus L to be less than epsilon. That's my ultimate goal. I need to start somewhere, absolute value of x minus a, less than delta, and I have to end up at this point right here. So, what I'm going to do is I'm going to start at what I need at the end, which is right there. That's where I'm going to start. That's what I need. So let's just do some manipulating. Okay, this is called background work. So I need 5 halves x minus 5 absolute value to be less than epsilon. That's what I need. I'm going to factor out a 2/5, or multiply through by 2/5, factor out a 5 halves or multiply by 2/5, however you want to look at it. So I multiply both sides by 2/5, and I got absolute value of x minus 2 is, oh, that's interesting, because remember x was approaching 2, I believe. So that looks like what my delta is going to be. So here comes my proof. The limit, I'm going to let delta equal 2/5 epsilon. So if 0 is less than the absolute value of x minus 2 is less than delta, then the absolute value of x minus 2 is less than 2/5 epsilon. So I'm going to multiply both sides by 5 halves, distribute the 5/2 inside, and then cleverly rewrite it. So basically, I wrote the work backwards. Now, of course, to do this sort of required me to know the limit to start with. That's where it gets kind of interesting. So you may or may not have noticed something yet. If you have, then this assignment will be easier. If you haven't, then it might be a little bit harder. So use the idea from the previous problems, which were 3 of them, to prove that the limit as x approaches a of mx plus b is equal to am plus b. So we want you to prove that, okay? And this is what you have to do and turn in. So be a little bit careful in your work. There's for the most part, I think all of you are going to kind of be on the right track, but there's one thing in there you really have to be careful of. And m is a real number, by the way. So there's one thing that you have to be careful of, and I want you to watch out for that. So discuss why this problem isn't really too difficult, and why, I forgot the word why in there, okay, and why the proof actually makes sense. So you can draw a graph to help you with the proof, but again, there's one little thing you want to be really careful of. And this will be due on whatever PCR says. So I'm going to go with probably Monday morning. Anyways, that's the extent of my singing. So thank you and have a good day, and I hope you like the little pointer effect.